Hello guys, welcome to video session 3 of Notebook Mathematics chapter 1 number system of class 9. So in this session we will read about real numbers and their decimal expansion. Real numbers का decimal expansion कैसा होता है और decimal expansion के बेस पे हम उनको rational और irrational बताएंगे, right? So coming to this, in our NCERT textbook example 5 is given as find decimal expansion of 10 upon 3, 7 upon 8 and 1 upon 7. So we will start dividing these numbers, right? Numerator part is 10 and we have to divide by denominator, that is 3, right? So 3 3s are 9 and this division process will continue, okay? And we find that on completing division process we get the quotient as 3.333. that means after decimal the number is being repeated, right? So this type of decimal expansion are called non-terminating. That means this decimal expansion is not an, that means it is not having an and, right? And it is repeating continuously, right? One digit after decimal is being repeated continuously. 3333, it can be written as 3.3 bar. This means this number 3 is being repeated after decimal point, right? So therefore this type of decimal expansion is called non-terminating repeating decimal expansion. Now consider this example, 7 divided by 8, right? It is a fraction and here numerator part is 7 and we have to divide it by 8. So simply we have done the division procedure and we find that the remainder comes out to be 0. In the previous question the remainder was not coming 0. See here, 1 1 1, all time the remainder was the same, 1. But here the remainder turns out to be 0. When remainder is 0, we find that there is no further division possible and our quotient parts come to an end. That means this is a terminating decimal, terminating decimal expansion because quotient came to an end, right? Now one more example is given, 1 upon 7. We have to divide 1 by 7 and we find that on division this first we have introduced decimal, then 0 came here, 7 ones are 7, then 3 is left, one more 0 we can take as we already introduced decimal. So 0 came here, right? 7 4s are 28, 2 is left, again I can introduce 0, 1 0 I can take because I already introduced point, that is decimal over there. So in this way, after this many steps from here to here, I find that the remainder comes out to be 1. That means if I take one more 0 over here, this part will become the same as the point from where the number from where we have started our question. That means again this steps will be repeated. So procedure will repeat again from here to here, right? So till here I have wrote the quotient part as 0.142857. So the quotient part after decimal will repeat again from here. That means it will be something like this, 0.142857, again 142857, again 142857. Like this it will go on repeating. So here 6 numbers are being repeated, right? So this type of decimal expansion is also called non-terminating. Here there is no end, right? Non-terminating. Recurring means the part of numbers after decimal are repeating again and again. So this is also non-terminating recurring type of decimal expansion. So since now we have seen two types of decimal expansion, one is terminating decimal expansion and non-terminating and recurring, that means repeating type of decimal expansion. So one more type of decimal expansion is there, that is non-terminating also and it is non-recurring also, right? It may be because if I will give you an example, suppose that this is a decimal expansion, 0.10, 100, 100, 1 4 zeros and so on. So in this decimal expansion I can see that after the decimal it is non-terminating. See, continuous it is, right? There is no end. And one more thing, no digits are frequently being repeated in a same manner. It means this type of decimal expansion is non-terminating as well as non-repeating decimal expansion. So far we have seen that for this we have not mentioned this number in the form of rational number, right? So these two, that is non-terminating repeating as well as terminating decimal, are previously in the form of rational number. That means these two are rational numbers. But this is not rational. So as we cannot mention this in the form of p by q, this will have number form as irrational numbers. So based on decimal expansion, we can tell that whether the decimal expansion will have the numbers in the form of rational or in the form of irrational. So a terminating decimal expansion will always be in the form of rational number. A non-terminating recurring type of decimal expansion will also be in the form of rational number, but a non-terminating, non-recurring type of decimal will be in the form of irrational number. And now we will try to convert, see, terminating to rational number, non-terminating to rational number, right? But this is not possible and we will not do in this 9th standard. Clear? So now let us look how to convert terminating decimal expansion into rational number. To convert 0.875 into rational form, right? Rational number form we have to convert this. So it was same question we have seen here, 0.875, and our answer was 7 by 8. So we will convert this also, right? So simply, if you need to convert a terminating decimal expansion into rational form, we will write this number 0.875 and we will change it into fraction form. How? So we will write this number 0.875 without decimal. So decimal will change into 1 in the denominator part and the numbers after the decimal will change into 0. Now it is 875 divided by 1000. So I have to reduce it. So I will reduce it. So it is divisible by 25, right? 25 3 is 75, right? 12 is left, 125, 25 5 is 125, 25 4 is 100, 0 is left. It is divisible by 5, 5 7 is 35, 5 8 is 40. So this is my number in the form of rational number, right? So now our next topic is to convert non-terminating recurring decimal expansion to rational form. Now consider example 7 in NCERT textbook. Show that 0.333 and it is being continuous is equal to 0.3 bar, where can be represented or can be expressed in p by q, where p and q are integers and q not equal to 0. It means we have to express this in the form of rational number. What is rational number? A number in the form of p by q, where p and q are integers and q not equal to 0. That means we have to show that this number 0.3 bar can be expressed in the form of rational number. So we will begin our question, right? So let us assume a variable x is equal to 0.333 and so on. Now how many numbers are being repeated over here? A single number. If single number is there, multiply the given equation by 10. If 2 digits are repeated, multiply by 100. If 3 are repeated, multiply by 1000. I will explain you it. Suppose the question is 0.47 bar, that means 47 is repeating, or I can write 0.474747. Then you will first denote this as x equal to 0.474747 like that, right? And then you have to multiply this equation by 100. Why 100? Because 2 digits are repeated, therefore 2 zeros we will take. Understood? Now suppose it is like this, 471 bar, right? So 471, 471, 471. So continuously 3 digits are repeated, right? In this case, you will multiply by 3 zeros and 1, that is 1000. Understood? So it is like this. And if suppose the question they can give us like this also, 0.003 bar, right? So you should not do an error here by multiplying by 1000, because here only one number is repeated. So we will multiply by 10 only. Clear? So we will move over this topic. So let us assume x is equal to, x is equal to 0.333 and so on, right? So I told you we have to multiply by 10 because one number is repeating. So multiplying above equation by 10. So on LHS side also I have to multiply by 10. On RHS also I have to multiply by 10. Right? So 10 multiplied by x, you will get 10x. Here 1 0 is there. Right? So by multiplying by 10, you have to move the decimal to one digit after the. You have to move this decimal on after one digit on the right hand side. So this can be written as 3.33 and so on. Means this decimal has moved from here to here, right? Now this is my second equation. This is my first equation. So subtracting equation 1 from 2. इसका मतलब इस इक्वेशन को इसमें से माइनस कर दे. So I am writing this equation 10x equal to 3.33 and so on. Below that I will write that equation, x is equal to 0.33 and so on, right? And I will subtract. To 10x minus 9x you will get 9x. 10x minus 9x you will get 9x. Then after decimal the numbers are same. So you will get nothing. So 3 minus 0 you will get here 3. This will be full. On subtraction you will get 0 over there, right? So after decimal, if it is 0, I can write also 3.0 means it is 0. It is 3 only. So 3.0 means it is 3 only. So 9x is equal to 3. So x is equal to, here it is in multiplication form, so it will come over here. So 3 1s are 3, 3 3s are 9. So x is equal to 1 by 3. And also this x was equivalent to 0.333, right? X is also equal to this. X is also equal to this. So this decimal expansion is now being represented in the form of P by Q. That means this is rational form of this decimal expansion. So in this way you can convert any non-terminating repeating numbers into its rational form. Right? So many questions are there based on this in our NCERT textbook which can be solved. Right? So exercise 1.3 question number 3 is purely based on this method. Question number 4 is also based on this method. Then example 8 and example 9 is also based on this method. So have so refer once these two, so you can easily solve these two questions. Question number 2 of exercise 1.3 is the decimal expansion of 1 by 7 is this, as we have seen in our previous section. See, 1 by 7 can be written as 0.142857 bar. So they wrote this. So we need to find the value of 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7, but without long division. So it is simple. See, 2 by 7 can be written as 2 multiplied by 1 by 7. See, 2 multiply 1 is 2 only, and 7, 2 by 2 multiply 1 by 7. And we know the value of 1 by 7. So 1 by 7 is 0.142857 bar. So simply multiply this and you will get the answer. So it is, you just have to multiply this number by this decimal expansion and you will get the answer. So similarly 3 by 7, so 3 multiply 1 by 7, so 3 multiply the value of this 0.142857 and you will get the answer. In this way you have to proceed and you can find all the values. So coming to exercise 1.3, question number 1 is based on example 5 which we have seen. They have given us numbers like this 36 by 100 and we have to convert it into decimal expansion form and we have to tell which kind of decimal expansion it is, whether it is terminating decimal expansion, whether non-terminating repeating, or whether it is non-terminating non-repeating, right? So they have given a few questions and you have to solve this based on example 5 which we have discussed. Now question number 2 we have already discussed in previous section. Now question number 3 and question number 4, as I have given you in the previous section, they are conversion of a non-terminating repeating decimal expansion to rational numbers. So you have to proceed as per the example we have discussed over there, that is example number 7. Clear? That we already discussed. Now coming to this question number 5, what can be maximum number of digits? Question number 5 is what can be maximum number of digits be in a repeating block of digits in the decimal expansion of 1 by 17. So simply you have to divide this 1 by 17, that is you have to divide 1 by 17 and you have to find out the decimal expansion, that how many numbers are being repeated and after what certain period of time, right? So once you find the remainder same as the previous remainder, at that time you will stop that and you will show that this many numbers are being repeated. It is very long division expansion, right? Decimal expansion type of division. So perform this. Means it is similar to that 1 by 7 we have shown. I will show you again. This one. See, 1 by 7 was there. We have performed the division. After certain period of time, we find that the procedure will again repeat. So at that point, you stop the division and then you will show that decimal expansion. Understood? Now coming to question number 6. Question number 6 is very simple. It is reasoning based. So it is homework which we will discuss in the later section. So question number 7. Question number 7 is write 3 numbers whose decimal expansion are non-terminating and non-recurring. It is up to you. So 3 numbers you have to write which are non-terminating as well as non-repeating. यानी वो एंड भी नहीं होना चाहिए नंबर और साथ में उनका कोई भी एक डिजिट एक पैटर्न में रिपीट नहीं होना चाहिए. मतलब मैं ऐसा नहीं लिख सकता किसी नंबर को लाइक 0.371371 आप तो कहोगे सर ये रिपीट नहीं हो रहा. मैंने कहा हाँ बिल्कुल रिपीट नहीं हो रहा है, लेकिन सॉरी ये तो एंड नहीं हो रहा, लेकिन हाँ बिल्कुल ये एंड नहीं हो रहा, लेकिन इसके साथ साथ ये क्या होना चाहिए, रिपीट भी नहीं होना चाहिए. यहाँ रिपीट हो रहा है, देखो 371 ये रिपीट हो रहा है. तो हमें ऐसे नंबर्स लिखने 3 नंबर जो नॉन टर्मिनेटिंग हो, मतलब एंड उसका नहीं होना चाहिए और साथ साथ वो रिपीट भी नहीं होने चाहिए. सो एक नंबर जैसे मैंने अभी थोड़ी देर पहले लिखा था 0.10, 100, 100, 1 4 zeros एंड सो ऑन। सो इट इज नॉन टर्मिनेटिंग, इसका एंड नहीं है, और साथ में इसमें कोई भी एक तरीके के पैटर्न में कोई नंबर्स रिपीट नहीं हो रहे आफ्टर डेसिमल एक्सपेंशन। तो हमारा हो गया। ऐसे आपको दो और लिखने, कुछ भी लिखो, 0.121, 221, 2221, 22221, बस। ये भी नॉन टर्मिनेटिंग है, कुछ भी यहाँ पे देखो एंड नहीं है इसका, एंड नॉन रिपीटिंग, यहाँ पे कोई भी चीज़ रिपीट नहीं हो रही है आगे। तो ऐसे आप कितने भी नंबर्स लिख सकते हो, इन्होंने तो सिर्फ 3 नंबर्स का है। इट इज़ वेरी सिंपल, राइट। क्वेश्चन नंबर 8 पर, तो क्वेश्चन नंबर 8 ये कहता है कि फाइंड 3 डिफरेंट इरेशनल नंबर, 3 इरेशनल नंबर हमें ढूंढने हैं ये 2 रैशनल नंबर्स के बीच में, इन 2 रैशनल नंबर्स के बीच में हमें 3 इरेशनल नंबर्स ढूंढने हैं। तो सिंपल सी बात है, इरेशनल नंबर कैसे होते हैं, यानी हमने जो पिछले सेक्शन में लिखा था, ये जो नंबर्स है ये क्या है, ये नॉन टर्मिनेटिंग नॉन रिपीटिंग। इसका मतलब इस तरीके के नंबर्स को हम क्या कह सकते हैं, इरेशनल नंबर्स। तो इरेशनल नंबर अगर मुझे लिखना है तो मुझे पहले इनको किस फॉर्म में लाना पड़ेगा, डेसिमल फॉर्म में और रैशनल नंबर को डेसिमल फॉर्म में, इरेशनल नंबर को भी डेसिमल फॉर्म में लिखा जा सकता है ना। तो हम सिंपली इनको क्या करेंगे, डेसिमल फॉर्म में कन्वर्ट कर देंगे और बाद में उनके बीच में हम 3 नंबर्स कुछ भी सेलेक्ट कर लेंगे, राइट। सो सपोज दैट 5/7 है, तो 7 से 5 को डिवाइड करना है। वैसे ही 9/11 है, तो 11 से 9 को डिवाइड करना है। यहाँ हमने डिवीजन कंप्लीट कर लिया है। सो 5/7 को जब डिवाइड किया गया तो ये नंबर आ रहा है 0.714। 9/11 को जब डिवाइड किया तो आया 0.818। तो ये ऐसा नहीं होगा 0.714 और 0.818 के बीच में आपको 3 इरेशनल नंबर लिखने हैं। तो 0.71 और 81 के बीच देखो हम नंबर ऐसे स्टार्ट कर लेंगे, 72 होता है, 73 होता है और 74 होता है। ये हमें मिल गए 3 नंबर, 71 था स्टार्टिंग में और यहाँ 81, तो हमने लिख दिया 72, 73, 74। अब इसके साथ आपको बना देना है इनको इरेशनल, यानी नॉन टर्मिनेटिंग बनाना है और साथ साथ में क्या बनाना है, नॉन रिकरिंग, है ना। तो 7 2 आ चुका था तो हमने लिख दिया 0 0, फिर से लिख दिया हमने 2 0 0 था तो 3 0 0 0, 3 0 लगा दिए, 4 0 0 0 0 एंड सो ऑन, कुछ भी बना लो यार। अब 7 3 आ गया तो इसके साथ भी यही पैटर्न लगा लेंगे, 0 0 4 0 0 0 5 0 0 0 0। आप अपने मन से कुछ भी बना सकते हो, इसको कंप्लीट कर लो, बस यही है आपका आंसर। Coming to the last question of our exercise, classify to rational और irrational। सबसे पहला क्वेश्चन है रूट 23। सो हम लोग जानते हैं रूट 16 जो होता है वो होता है 4 और रूट 25 जो होता है वो क्या है 5। सो रूट 23 तो इनके बीच में आ रहा है, दैट मीन्स ना ही रूट 16 है ना ही रूट 25 इनके बीच में, तो इनकी कुछ वैल्यू होगी दैट इज अननोन, राइट। सो ये वैल्यू रूट में ही रह गया है, तो ऐसे नंबर्स को हम क्या कहते हैं डायरेक्टली इरेशनल। अगर वो नंबर उसका रूट ओपन हो जाता है और वो कुछ इस फॉर्म में आ जाता है इंटीजर फॉर्म में, तो हम उसको एक्सप्रेस कर सकते हैं रैशनल में। लाइक इसको मैं लिख दूँ 4/1 हो गया रैशनल, 5/1 हो गया रैशनल, लेकिन इसको हम रूट से बाहर नहीं निकाल सकते, तो अभी के लिए ये कैसा है इरेशनल नंबर। रूट 225, तो देखो भाई सिंपल है, रूट 225 ये होता है 15 का स्क्वायर, 15 का मतलब 15 का स्क्वायर होता है 225। तो मैं इसको लिख सकता हूँ 225 15 स्क्वायर, 15 मल्टीप्लाई बाय 15 होता है 225। तो कोई भी नंबर अगर 2 बार मल्टीप्लाई होते हैं तो हम उसको स्क्वायर लिखते हैं, 15 स्क्वायर इज 225, तो स्क्वायर और रूट ही कैंसिल, ये नंबर हो गया 15। अब इसके नीचे 1 लगा तो ये बन गया रैशनल नंबर। अब आते हैं इस पे, अब ये तीनों डेसिमल एक्सपेंशन टाइप के हैं। मैंने आपको बिगिनिंग में ही कहा था अगर टर्मिनेटिंग, दिस इज टर्मिनेटिंग डेसिमल, एंड हो गया इसका टर्मिनेटिंग डेसिमल। सो अगर टर्मिनेटिंग डेसिमल एक्सपेंशन है तो वो क्या होता है, वो होता है रैशनल नंबर। ये नॉन टर्मिनेटिंग है तो नॉन टर्मिनेटिंग है, राइट। इसके साथ साथ ये नॉन टर्मिनेटिंग है और उसके साथ साथ देखो 478 478 रिपीट हो रहा है, तो इसका मतलब ये नॉन टर्मिनेटिंग के साथ साथ रिपीटिंग है। और अगर ऐसा हो तो हमने फिर क्या कहा था, ये भी होता है रैशनल नंबर। और अब यहाँ पे देख रहा हूँ मैं, ये क्या है, नॉन टर्मिनेटिंग और कुछ भी रिपीट नहीं हो रहा है। देखिए पहले 10 है, फिर 100 है, फिर 1000 है, कहाँ है रिपीटिंग? सो रिपीटेशन नहीं है, तो इट इज नॉन रिपीटिंग। सो देयरफॉर इट इज नॉन टर्मिनेटिंग और नॉन रिपीटिंग है, तब तो वो क्या हो गया, इट इज इररेशनल नंबर। क्लियर? इसी चीज को एक बार हम पहले आगे भी डिस्कस कर चुके हैं, तो एक बार चेक कर लेते हैं ताकि आप लोग को अच्छे से याद रहे। देखिए रैशनल नंबर्स एंड देयर डेसिमल एक्सपेंशन, मैंने कहा था अगर टर्मिनेटिंग हो तो वो होता है रैशनल नंबर, नॉन टर्मिनेटिंग पर रिपीट हो रहा हो तो भी रैशनल नंबर होता है, और नॉन टर्मिनेटिंग नॉन रिकरिंग तो भी रैशनल नंबर होता है, राइट? तो सिर्फ टर्मिनेटिंग के केस में रैशनल होता है, नॉन टर्मिनेटिंग रिकरिंग है तब भी रैशनल, और नॉन टर्मिनेटिंग के साथ साथ नॉन रिकरिंग है तब इररेशनल नंबर होता है, राइट? इसको इन्होंने लास्ट क्वेश्चन में रिपीट किया है, तो अच्छा रिविजन करा दिया इन्होंने कि ये जो टर्मिनेटिंग डेसिमल है वो क्या होता है, रैशनल नंबर होता है। नॉन टर्मिनेटिंग यानी एंड ना हो और बार बार कुछ नंबर्स रिपीट हो रहे हो तो भी वो रैशनल नंबर होता है, और नॉन टर्मिनेटिंग के साथ नॉन रिपीटिंग, कोई भी चीज़ रिपीट नहीं हो रही यहाँ पे, तो वो होता है इररेशनल नंबर।